Can you hear me?
Yes, sir. It is audible, sir.
Okay. So this is my agenda. RAG applications. Small intro about LLM. Then components of RAG. The mathematical model of RAG with the example code. Then final demo. First of all, what is RAG? What is the purpose of RAG or LLM? I hope all of you know about LLM, large language model. So without RAG, we cannot retrieve any relevant or document or relevant answer from LLM. LLM means ChatGPT, uh, the others. So RAG means it is an AI from framework so that combines retrieval of relevant document with generative AI models. It helps LLM to give accurate fact-based answer without hallucination. So main objective of RAG is to retrieve the relevant documents. So when we ask the query to ChatGPT, immediately it gives the relevant answer or relevant document, whatever it may be, image or it may be text document. So that document relevant to our query, our answer. So the main heart of the LLM is RAG. So see this picture, RAG inject real document while answering. So RAG inject the real document. So based on the document, our LLM trained. LLM will be trained based on the real document. Then we give the prompt, it gives the correct answer. So this is the main objective of RAG. Then next, without RAG, LLM produce a hallucinate, which means when required information is missing or when required information is unclear or when required information are ambiguous, so large language model may fill the gap with incorrect content. So that is called hallucination. Uh, Simple example, uh, LLM does not have the relevant document, does not have the document. See the picture here. I am asking about 2027 syllabus from the LLM, but LLM does not have 2027 syllabus. So immediately what LLM does means it gives the fake information or incorrect information to the user. So this is called hallucination. So without RAG, LLM does not give the correct answer or relevant document. Then LLM cannot know your private college or personalized data. In general, for ChatGPT, you take any LLM, uh, does not have the personalized data. So when we make the LLM as personalized LLM, we are using RAG. So RAG provide the, for example, I'm taking simple ERP in which have student record and college data and some other relevant document related to college or university. So these relevant document give us an input to the LLM, my LLM. So my LLM trained with this student data. This is called personalization. The same way you can give any kind of, you can train any kind of personalized data like ERP or healthcare data or retail, etc. Then your LLM give the uh, relevant answer based on the query. So query may be related to your ERP. What is my how many student in AD department, how many students in CSE department, what is a required pass percentage. So these kind of personalized of ERP data trained with LLM with the help of RAG. So without RAG, we cannot personalize our LLM like GPT. So these are the three main goal of LLM. These slides show some 4 real life application of RAG. First one is in education, we can design personalized ERP as a chatbot. So we can query related to education. Come to healthcare, the same way we using RAG, we give the healthcare or personalized healthcare data to the LLM, then train with personalized healthcare data. Then we ask a query related to healthcare. The same way, legal sector, the same way, industry business. So before going to in-depth knowledge of LLM, we just know, RAG, we just know intro about LLM. I hope all of you know what is LLM. It stands for large language model. See this diagram. This is a large language model. It just accept the text as a input. It gives the text as a output, and also it gives the what is a next word. So this is a task of LLM. So these output mostly relevant to the RAG. We can see some of the LLM. First one is Anthropic. It is safe and long context AI. These models are designed to be safe, good at reading long document. The main objective of this model, LLM model, first one is CLAD, used for safe conversation. For example, a college ERP chatbot answering students' queries. Simple, it gives the simple answer, required answer. Then come to CLAD 2 model, good at long document analysis. For example, we can upload 200-page anonymity regulation PDF, then ask him like summarize exam rule for final year students. It gives the relevant answer. To come to CLAD 3, it is strong in legal, policy, complaints, research summaries. For example, a college administration using it to summarize UGC guidelines or AICTE guidelines or NAC guidelines. So it gives the relevant content. So why use it? So these LLM give the safe answer, handle large PDFs, large policies, large reports. The next LLM, open source bar research, which can be customization and cost control. One kind of LLM is called Mistral. It is lightweight and fast LLM. For example, a simple startup company build an internal chatbot for employee without paying API fees using the Mistral LLM. The next one is Falcon. So it is strong in academic research and multilingual task. For example, using this Falcon, using the research lab for NLP experimentation. So all these LLMs are free. It is open source. You can download, you can customize the LLM based on your problem statement. Then Bloom, it supports many language, including low resource one. For example, translating study material into regional language. So Hindi translated into Tamil, Tamil converted into Hindi. So we can translate into native language. Then come to GPT Neo. So it is an open alternative to GPT. It is open source. For example, student experimenting with a text generation project or mini chatbot, so we can use this LLM, GPT new and GPT J. The next, domain specific LLM. It is specific for particular domain. We take bio GPT. It is trained on biomedical text. So this GPT LLM trained on biomedical text. For example, summarize research paper on cancer or genetics. It gives the relevant content or document. Then next one is MedPalm. It is focused on medical knowledge. It is focused on medical knowledge. Just a minute. Hello. Madam, சொல்லுங்க. இல்லை 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 மேடம். இருக்கு. ஹெச்ஓடிக்குள்ளே போய் பாருங்க, உங்கள் இது வரும். பிரச்சனை இல்லை, பிரச்சனை இல்லை. ஓகே. Sorry. Come to MedPalm. It trained on medical text. Example, summarize research paper on cancer genetics. Then code Llama. So these LLM trained on programming code. For example, helping students with debugging Python code, generating Java programs, explaining algorithms. So this kind of code generation, debugging, software development trained by code LLM. The next one, Google. I hope all of you know Gemini, Palm, and BERT. And right side, Gemini accept multimodal input. One is text and another one is image. So we can give the text who is a person and what is he know for, and also upload the image. It generate the response. It give the relevant content. Then come to Meta LLM. So it is efficient open source model for research. We can customization this LLM for industry use. First one is Llama. It is a first version. It is a Meta's first large open source model. It is designed to be efficient. It perform good with a fewer parameter. For example, use case, university research project. A PhD student use LLM to study how language model understand grammar. Then student can use this Llama to run experiment on a local GPU instead of costly cloud server. So here we need not have costly cloud server, just we can run on the local GPU Llama model. Then next one, Llama 2. It improved version of Llama. It is free for commercial use. It is better chat reasoning and safely. So for example, a college chatbot, a college built on internal chatbot using Llama 2. So it give answer admission to frequent answer questions, then explain rules and regulations. It run fully on the college server. And last one is Llama 3. So it is the latest and most powerful version of Meta LLM. It is much better reasoning, coding, instruction following. It compete with the top commercial model. The example use case: the software development assistant, a startup company use this Llama 3 to generate Python and Java code and debugging error, and it help developer write documentation. So this kind of stuff we have to done by Llama 3. Then ChatGPT, I hope all of you know, this is a evaluation of ChatGPT. I'm not spend much time in this slide. Then what LLM do? Considers this diagram. So I have a LLM. When I'm giving input as I, immediately my LLM predict the next word. Here, what is the next word? Have. Then input and output again given as a input to the LLM fed forward technique. Now the input is I have. What is a prediction of LLM? Next word yeah. Then I have a as a next input to the LLM. Then my predict next word is dream. Then I have a dream. Then stop. So this is what LLM will do. Come to our topic RAG. So these are core components of RAG. Here have embedding, then cosine similarity, then vector DB, then final llama, then sentence transformer, PERT. So this is a main component of RAG. This is another architecture. This is my document. My document split into different chunk of text. Then each text given as input to the embedding generation model. So this embedding generation model convert the each string into vector. So that vector store in the vector database. So this is an example of vector database: FAISS, Chroma, Pinecone. Then user give the query. Is a user given as a query. So that query given as input to embedding generation model. So this embedding generation model like transformer, it convert your query into vector. Now the query embedding vector store into vector database. So already I have the different chunk vector. So these user query vector then match to existing vectors. Then it retrieve the top k matches, then given to the LLM, ChatGPT, Llama, Mistral. So now this LLM generate the answer. Answer may be text or image. So now the user get the relevant document, relevant text. So this is a flow of RAG. I explain one by one. This is another typical architecture of RAG. My document, each document split into different chunk, and that different chunk converted into vector, and all the vectors store in the vector database. User give the query, then this query converted into vector. This match with already stored vectors in the vector database, then retrieve the relevant document. Then again this augment section, the prompt, relevant prompt or relevant context match with your query. Then these top 5k matches given as a input to LLM, then it generate the response. Now user get the relevant answer or relevant document. This is another typical architecture of RAG. Let's come to mathematical foundation. Embedding computation. This is my query Q equal to E of query embedding. E stands for embedding, E of query. This is my D I equal to E of document I. Document 1 equal to embedding of document 1. Then I use a cosine similarity equal to, this is a cosine similarity formula. My entire query, the first Q is a query dot Q is a first document. Then this is a magnitude of my query, magnitude of first document. If I have a n document, your query, this formula, your query make the dot product it 1 to n document. It's match with your query with n document, up to n document. This is example for, this is my content, this is my document. So document contain Ramco Institute of Technology follow a 75% attendance requirement. The students with 65 to 74 attendance may submit the medical certificate. This is second sentence. Third sentence, students below 65 are not eligible to write the semester exam. This is my document. So now RAG have the 9 module to give the, to generate the required answer or document. First PDF was text injection, then text cleaning, chunking, embedding, vector DB, query embedding, similarity checks, context retrieval, LLM generation. Then first module PDF or text injection. The purpose of module 1 is, so I can load the PDF, I can load the Word file content, I can load the text content into using Python language. This is a simple code with open document sample.txt. This sample.txt have this document. Okay. Then module 2, text cleaning. The purpose of this module, just it remove the extra spaces, remove the special character, then normalize the text. Just you apply this replace function. The result for our text is Ramco Institute of Technology follow a 75% attendance requirement. Then student with 75 to attendance may submit. So everything became a clean, readable, single paragraph. So output of this module to normalize your text. In module 3, chunking process, text splitting. So purpose of module 3 is, so I have a document, my document split into different chunk. So here chunk size is 150 character. This is a code, Python code, clean text of I:(i) plus 150 for your text. So my chunk one is 150 character, maximum chunk size is 150 character. So for first, my document first line is Ramco Institute of Technology follow a 75% attendance requirement. This is a first chunk. Second chunk represent the second sentence. Third chunk represent the third line or third sentence. The students below 65% are not eligible to write the semester exam. So my document now split into 3 chunks. Each chunk have the 150 characters. And module 4, embedding. Now I have a different chunk 1, 2, and 3. So these chunks into numerical vector that capture meaning. So module 4, embedding means convert the text content into vector. That is called embedding. Here there is a code sentence transformer is a embedding technique. So this sentence transformer convert my chunk into vectors. See the diagram. Uh, this is my output. My first chunk data is Ramco Institute of Technology follow a 75% attendance requirement. This is my first chunk. So this text converted into vectors. This is a vector value. This is a vector value. Second chunk, this is a second sentence. So this second sentence text converted into the same vector. Then third chunk, so each chunk become a 384 dimensional vector, which means it maximum support 384 dimensional vector. So all the three chunks store into embedding database. So embedding generation model is a sentence transformer. Sentence transformer. This is a embedding generation model. So this sentence transform model convert your all three chunk into vectors. So these embeddings, these vectors then store in the vector database. This is a module file, vector DB. FAISS or Chroma, these are the vector database. So purpose of vector DB, it store vectors, my vectors. The system can search which chunk is most similar to the question. So all the your document now converted into vector. So all the vector stored in vector database. Okay, this is a simple code. FAISS, it is a vector DB. It store capable of maximum 384 dimension vector. Then my converted vectors are stored in the vector object. Then add all the vectors into the my database. Index is a database object, vector database object. So now all the converted vectors stored in the FAISS vector database. Then module 6, query embedding. And the purpose of query embedding, convert user question to vector. Now come to the my query. User give the query. My query is what is the minimum attendance required. My query is what is the minimum attendance required. Now my user query again converted into vector using encoding technique. My query is converted into vector. So what is the output vector for my query? This is a vector. Okay, what is the minimum attendance required? This text converted into vector. Now my query converted into vector. My query converted into vector. The same query again store into vector database. Now my query vector and my document vector put together store in the vector database. I hope you understand. Then come to module 7, similarity search. In general, it follow the nearest neighbor algorithm to find the similarity search. Purpose of my module 7 is to find which chunk is closest to the questions or query. So I have a 3 chunk. Now our example, we have a 3 chunk 1, 2 and 3. Which chunk most closest to your query? This is a purpose of module 7, similarity search. This is a simple Python code. Index is my vector database. My vector database have all the vector data. Dot search function. This is my query vector. This is my query vector. I pass my query vector into vector database. This query vector search to the already existing converted all the 3 chunks vectors. So now the similarity search technique will be happen. Okay. So my closest chunk is chunk 1. So Ramco Institute of Technology follow a 75% attendance requirement. This is my query. This is my query. So what is a vector of this query? This is a vector of this query. Okay. So all those stored in the vector database, then perform similarity search. The module 8 context retrieval. It retrieve the relevant chunk. Here, chunk 1 is relevant to or closest to my query. Okay, chunk 1 vector is relevant to vector of my query. So this is a relevant document, relevant text. So this chunk 1 is given as an input to LLM, and LLM give the next word or add some extra relevant text into the chunk 1, that given as a answer to the user. Module 9 LLM generation. LLM generate the response. Here LLM.generate your context, your query. Based on the context, based on the query, your LLM generate the response. That is the answer. What is my answer? What is the output of LLM? The minimum attendance required is 75%. This is a response generated by my LLM based on the all the process. You can see the slide how FASS, my vector DB, written the most similar chunk. First 0 chunk 75%. 1 medical certificate allowed. 2 below 65 not eligible. What is a vector for this 01, 03, 0.5. Here 0.8, 0.1, 0.0. For this 0.0, 0.9, 0.4. What is my query? What is the minimum attendance requirement? What is a vector of this text? 0.2, 0.4, 0.6. To compare this vector with first text, it is most relevant, most similar. 0.2 here, 0.1. 0.4 here, 0.3. 0.6 here, 0.5. So this vector most relevant to this vector. So this is a answer. This is the most relevant text or most relevant document. Then my vector database compute the distance between query vector versus each chunk vector. My query versus each chunk. So now my document have 3 chunks, chunk 1, 2, 3. Chunk first find the distance between chunk 0 vector versus my query vector. This is my query vector 0, 0.2, 0.4, 0.6. What is a vector of chunk 0 sentence? 0.1, 0.3, 0.5. So this is a find the distance L2 distance formula. What is the output? 0.03. Come to second chunk. This is my query vector 0.2, 0.4, 0.6. Chunk 1 0.8, 0.1, 0.0. So you can see this. This is not relevant to this value. So you find the compute the distance. We will get the 0.81. Then come to third sentence. This is my query vector. Then third vector 0.0, 0.9, 0.4. These are not relevant to my query. So what is the distance? 0.33. Here, so we can take 0.03. The smallest distance is distance represent the closest to your query. I hope you understand. Smallest distance is because nearest neighbor. We apply nearest neighbor algorithm. So we take the smallest distance. So that represent my query vector closest to my chunk. Okay. You can see the diagram. So this is query and this is chunk 0. This is chunk 1, this is chunk 2. Sentence 2, sentence 3 represent. So this is a closest vector. Chunk 0 is a closest to my query. Here you can see this embedding space diagram. This dot represent the chunk 2, this dot represent the chunk 1. Chunk 0 query vector. So this vector most closest, smallest distance. So I can take chunk 0 is a relevant text or relevant document. We can see the heat map. Here this is a query, my query vector. This is my chunk vector, which is most closest to this. Again, we can embedding vector, then cosine similarity. Previously, I told this is a formula for cosine similarity. Q represent the query, C represent my chunk 1, chunk 2, chunk 3, up to 1 to n. So this is a dot product, then magnitude, vector magnitude product. My query and my chunk 1, chunk 2, chunk 3. What is the formula for cosine similarity? Cos of my query comma chunk equal to Q dot C, magnitude Q, my query, magnitude of C. Here value should be fall between -1 to +1. So +1 represent identical direction, 0 represent unrelated document, -1 represent opposite. So when I get +1, that is a relevant text or relevant document. When I get 0, it represents the unrelated document. When I get -1, it represents the opposite. Here, this is my query vector. This is my chunk vectors. Chunk 0, 1, 2. Then first query versus chunk 0. This is my query vector. This is my chunk vector value. When we apply dot product, then magnitude of Q, then magnitude of CO. This is a formula. I hope all of you know mathematic formula. Then cosine similarity. Perform this, we get the 0.99. It most closest to 1. So it is a very high similarity. Almost this represent the identical meaning. Then come to query versus chunk 1, query versus chunk 2. You apply same dot product, then magnitude of C1 and my query. Now get 0.332. It is low similarity, not relevant, because it is not closest to 1. The same way, apply chunk 2 dot product magnitude cosine similarity. I get 0.81. Compared to chunk 0 0.99. Here 0.81, which is highest similarity 0.995. So conclude that chunk 1 is a relevant text or relevant document based on our context. This is an example for cosine similarity search. Okay. Here chunk 1 is Ramco Institute of Technology follow a 75% attendance requirement. My query was, what is the minimum attendance requirement? This attendance requirement is a similarity with chunk 0. Semantically, both talk about required attendance. Okay, so embedding vector align very closely strongest cosine similarity. The summary of module 1, 2, 3 up to 9. Injection, read the file, example output, file full text. Then cleaning, normalize my input query, a single cleaned paragraph, and chunking, split it into different chunk. Here 1, 2, 3. And embedding my text converted into vector, maximum 384 dimensional vector it support. Then vector DB, it can store my converted embedding vector into vector database. This is a vector database. Then query embedding, again query is converted into vector, again store into vector DB. Then apply cosine similarity, which perform comparison or nearest apply nearest neighbor or cosine similarity technique. Then retrieve the extract chunk which is closest to my query. Then LLM generate the answer or response. When we see the demo, you go for this Polo Club GitHub IO. This we can visually how RAG will perform. So this is my query, how to integrate information retrieval into machine learning system. Here I run this query. This is my document. This is my entire document. This query input to RAG, then it get the top 5 similarity search, then given into LLM. This LLM generate the relevant content or text. This is a text. Okay. This is my text. This is my text. Text contain more. Imagine that here 10,000 document. So this 10,000 document initially converted into vectors. That vectors of 10,000 document store into your vector database. This is a process. Then this is my query. This query again converted into vectors. So that vectors also store into vector database. After that, already I have a vectors of 10,000 document, then vectors of my query. Then now apply the cosine similarity or nearest neighborhood algorithm to find the which content of 10,000 document is more relevant to my query. Okay, that is come to here. This is a context. Okay, so this content is a written by top 5 similarity content. This is my context. So this context again given as an input to your LLM. So now LLM generate the relevant content for this context. So this is a RAG with LLM combined together to generate the relevant document. And one more demo. And I have a Django framework here, chatbot, ERP. I hope visible my screen here. In chatbot, I have a folder called doc. In doc, I have 3 documents. One is Cognition company. Another one is Rewatcher hiring update, which contain relevant to this topic. Then Anna University syllabus. So I have a 3 PDF document. I have a 3 PDF document. So these 3 PDF document, initially what I'm going to do, these 3 PDF document converted into different chunks. Then each chunks converted into vectors. Then all the vectors stored into the FEISS vector database. Then I given as a query. Again, this query converted into vector store into vector DB. Then where similarity search will be happening. Then that top 5 search context given to the input LLM, the LLM generate the relevant document. And I run this. This is my output of LLM. I completed only for first component chatbot. I explore chatbot, click on export chatbot. First, I need to upload the document. That means rebuild knowledge base. It represent, I have a 3 document, 3 PDF. So I want to convert all the 3 PDF into vectors. Then all the vectors are into vector DB. So this button perform this task. So now rebuilding knowledge base from PDF. So what is happening here? So all the 3 PDF, first it will take first PDF, Cognizant PDF, which contain some relevant content of Cognizant CTS company. So they take first PDF. That first PDF have more content. Each content split into different chunk. Then all the different chunk converted into vectors. That vector stored in the DB. Again come to second PDF. Then third PDF. So all the PDF now store into vector DB. Then after building, user can give the query. What is Cognizant? Now building is going on. It take 2 to 3 minutes because all the PDF document is large. So this is a way, so you can build personalized LLM for any problem statement. We can see here output creating embedding 51% is completed. It take first one PDF, then second PDF, then syllabus PDF. In first PDF, here you can see 23 chunks. Cognizant PDF converted into 23 chunks, 150 character. Then next PDF converted into 15 chunks. Then analysis syllabus PDF converted into 2967 chunks. Now all the chunks store into FAISS vector database. Now completed. Vector store the built-in with 300Y chunks. So now my vector DB contain 3005 vector of respective chunks. This is the query. This is my relevant answer. This is my relevant answer. Okay, what is Cognizant? It gives the relevant answer. So this is way you can build your own LLM or personalized LLM. Thank you.